All right, so we'll talk about chapter 6 and review for the test. So which one did you want to start with?
So on the practice test, it's problem 2.
All
So I
right,
thought I'd done it correctly, but when I went back and viewed your video, I didn't. I just want to know where I messed up. Because you gave the
okay.
answer, but you didn't show how you got the answer.
All right, let's go through that. Let's see here. This is 2021 you said, or 2020?
Or 2020.
Yeah, 4 through 6. All right. So far, the tests I've been graded have been mostly really good, so I'm happy about that.
I got a B on my last one, and I wasn't
Well,
happy about that, but that's my own
well,
fault.
well, the good thing is, hopefully this, I think I got a fair, if you got B in every exam, but you did everything else excellent, you still essentially get an A in the class. So that's
As I did my orientation for Oklahoma State, and in order to get credit, I have to pass this class with a C. Now I want to
yep.
do better than a C, but
Yeah, you want to do better, yep. Yeah. Well, yeah, I don't think you'll have any problem. All right. Did you want to go over this first one at all?
no, that one I got easily. That one's good.
Okay.
Um,
Yeah. And
so
usually the only
20,
tricky parts on that is the given part. So like it says,
yeah,
what's a probability that they're traditional given they're in the quality group? Then you're only going to look at these 10 compared to these 33, right?
yeah,
Given whatever the second category is. All right. So number is the second one here. Is that right?
yeah. Number two, so
Yeah.
20L5. How do you I guess, do that in your calculator?
Oh, that's C. I'm sorry. That's a
Oh,
combinations.
see, okay.
So what I would suggest, what kind of calculator do you have? Just the regular?
TI-83.
Yeah. So that actually has a combinations button. You can also use Wolfram Alpha is another website that you can type it in, and just type in 20C, what was it, 20C5? Is that what it is?
Yes,
Yeah. And that should get you the 15,504. For your TI-83, do you see a stat button?
yes.
And then do you see where it says, maybe one of the tabs where it says like PRV for probability?
I have edit, calc, and tests.
Okay. Well, okay, you're in an 83. All right. So let me think here. Trying to memorize that.
It says
Go to,
TI-83
oh,
plus.
hit the math button
Okay.
in the home screen. Hit the math
Oh,
button.
yeah,
Now you
there's
should see,
there's probability.
yep. Hit that, and then you should see like options for NCR and NPR.
Yep,
So the combinations are if order does not matter, right?
yep.
So for instance, if I want the tallest players, it doesn't matter if I pick the tallest and then the next tallest and the next tallest. That's on a different team than like the fifth tallest and the fourth. You know what I'm saying?
Hmm.
So the order of those five individuals does not matter. We're just asking how many different combinations are there of teams of five, or like it's like asking the same question of how many committees could you make out of a team or out of 20 people. So if order does not matter, then use combinations. So are you able to do that? 20C5, does it give you 15,504?
So when I put it in, so do
Oh
I
yeah,
do 20 and
20
then
and
20
then hit that, and then hit the NCR button and then type in
and then do
5
5? Yep,
and then hit,
15,504. Okay,
there you go.
got it.
Now, another good follow-up question would be this: what if the order did matter? So
Then
for
it'd be
instance,
not
yeah,
C, but it'd be P. Separate
yes,
or
permutations. Yes.
permutation. Thank you.
So hit that one. Hit 20P5.
That's way bigger.
Yeah, like 1.8 million or something.
Yeah.
Yeah. So that's a lot different because then because even within that five per layer team, there's a whole bunch of unique combinations if the order does matter. Now that's the funny thing is like, they call it a locker combination, right? But when you have like a locker or a lock or whatever, does the order of the numbers matter?
Yes.
Yeah, for sure. So it actually should be called locker permutation, not combination. But yeah, I'm not going to change the English language, I guess, for everybody. But anyway, does that make sense?
Yes, it does.
Okay, very good. That's a great question. All right, excellent. Is there another one you want to go over on the exam here?
Um, and I guess it's probably going over um like
You do
number
this lottery
7
one.
through the
This is
rest of it.
similar. Like number
What?
3, you just want to kind of go. You just want to step through these.
Yeah, sure. Yeah, let's
Okay.
do that.
All right. So this one's similar, right? It's like
Hmm.
the lottery. Now, when you're doing the lottery and they start drawing numbers out, does the order of the numbers matter?
Yeah. Yes. The
So
order.
if I've got on my ticket, the first number is 25, but if they draw 25 later, it doesn't count.
I think so. I've never played the lottery, so
So they're gonna pull out, in this case, in this one, they're gonna pull out 5 numbers out
yeah.
of 35. If you get those 5 numbers right, you're a winner. Okay. Now, if you get 5, if the order that they pull out is different than the order that you wrote down, it doesn't matter. You're still
It
gonna win.
doesn't.
It's just, did you get those 5 numbers? So what do you think? Does order matter or not?
In the question, it does, because it said it
Yes.
has
In
to
the
be
first,
selected in.
it says, yeah. So part
Okay, so
one
yeah, so
says
that'd be an N.
has
That'd be an NPR, right?
very good. Yep. Yep.
Okay.
The top one's NPR, and then if order does not matter, then it's NCR. Very good. So it'd be
Okay.
35 P5 and then 35 C5. Cool.
Yep.
All right. Um, Number 4 here. Sometimes people get a little tripped up on ones like this. Um, the first thing is if we have an or situation, something or this, you just add those probabilities. The problem is if there's an overlap, like if there's some that would be counted twice because they're in both categories. In this case, there is. So it says 70% use brokerage firms, 30% trade stocks online, and 20% do both. So if I just add 70% and 30%, that's 100%. But that's not accurate. If 20% are doing both, we've counted that 20% in both categories, so we have to subtract them off once. And if I do a Venn diagram here, I'll do a Venn diagram. So here's a little Venn diagram of this. There's one, that's the brokerage firm, that's selling stocks, and the both. So if this is like 0.7 and this is 0.3, in the middle is 0.2, what really means is that it's 0.5 and 0.2, right? For a total of 0.7. And this one would be 0.2 and 0.1 for a total of 0.3. That's really the kind of the visual, which is how you get that 0.8 as your total if you add those 3 areas up. If I just add 0.7 and 0.3 together, I get 100%, but I've counted this area twice, which means you subtract off 0.2 once. Cool?
Hmm.
Any questions on
Yeah, that
that
one
one?
wasn't really too much of a struggle. That was, I guess, for me at least, pretty straightforward because
Cool.
you obviously can't have 100%, and so
Yes.
it's pretty easy to see that
Yeah.
the 20% is
But
overlap.
that's that. I tried to pick an example here that should make you go, boy, that's weird. It shouldn't be that. And then on part B, probability of choosing 2 in a row that randomly. So it's an and situation, this and this. And if it's an and, what do?
You multiply.
Very good. So we're going to go, so it's 30% and 30%. So there's about a 9% chance of that happening 2 times in a row. My joke is around my house, we don't want to use the word lucky. If so, like yesterday, I was golfing and I hit the ball into a creek, but it hit a rock and it landed onto the green. And some would say that was lucky, but I say, nope, we just observed a very rare event. So that's So let's say we wanted to have, for this problem, we wanted to do 3 times in a row. That'd be 0.3 times 0.3 times 0.3, or you could just take 0.3 to the third. So if we did that again, that'd be like 0.027. That's getting to be pretty rare, isn't it? And the threshold we're going to start using is 0.05. When we start observing things that happen less than 5% of the time, we start to go,
That's rare.
that's rare. Yeah, that's a rare event. So that's the terminology that I joke with my children. As soon as they say something's lucky, I'm like, no, no such thing. But there are rare events that happen, and they're special sometimes. All right, on C, now this is the one where people kind of get messed up. They need to recognize that this is a binomial situation. Binomial means there's 2 options, right? There's a probability of this happening, and there's a probability of it not happening. But then there's different ways it could happen, and how do we count all the ways it could happen? That's where we do the NCR. This counts how many different ways it can happen, and this is essentially the probability of that event happening. So if I want exactly 3 full-time brokerage, that means I want exactly 2 that are not. So, and how many different, because you could go full-time, 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 not, or full-time, not, full-time, not, right? There's how many different combinations. That's what this takes care of. 5C3 tells us all the different like groupings that could happen, that counts. And this is the probability of that exactly happening. I want exactly 0.7 to happen 3 times and exactly 0.3 to happen twice. And so now that you have your, now you know how to do combinations, right? So go ahead and type this one in and see if you can get this to work to get that 0.3087. What is 5C3, by the way?
10.
10. So there's 10 different ways you could get groups that are 3 yes and 2 no, right?
Mm-hmm.
And notice that 3 plus 2 is 5. So this is R and this is N minus R. That's how we get the 2. And N is the number of choices we're making. Were you able to get that on your calculator?
Yeah, I pressed the wrong button, so I had to go back.
Yep, that's normal. So that's the other good thing I would suggest. Don't just write down your answer. Write down the formula on the left. So if you fat finger a button or something, I can still give you, most of the credit. Or if not, sometimes I'll just give all the credit. I'm like, yeah, that's exactly right. I'm like, how did they get that thing? They just hit a wrong button, right? So I would strongly encourage showing the work here.
So now I got 0.03087.
0.03087.
Yeah,
Let me see
you got
what
0.3.
Let me see here. 0.7 to the third, right?
Yep.
3 times
The second
0.3
power.
to the second is 0.03, but now you have to take it times 10 because that's the combination.
Okay. Gotcha.
Yep. Times 10. Yep.
Okay.
There you go.
Now that makes more
That's
sense.
probably that of one of those, like that one way of happening is about a 3% chance, but there's 10 different there's 10 different combinations that work, so you have to take it times 10.
Okay, that makes more sense now.
Cool. Yeah, that's multiply there. Very good. All right. 5 is just trying to find the average of a probability distribution. Really, and if you look at the formula, it's just the sum of x times the probability of x. That's just the formula. So you just take what's the result? What's the probability that I get 0 claims? Well, 25%. 0 times 0.25 is 0. 1 times 0.15 is, right? So you just multiply those straight across and then you just add them up. So the average number of claims is going to be 1.8 per day.
That was pretty straightforward, yeah. And then you just do 1.8 times 5,000.
Yep.
And then you do 9,000 times 250. Then you divide that by 10,000. So that was pretty straightforward.
And this is how they do insurance, isn't it? I mean, that's kind of a cool problem to show. This is how they figure out, like, this is very simplistic, obviously, But it's in general, the philosophy behind all insurance is done like this. Now, actuaries know that this distribution right here is very basic, right? The truth is, okay, historically, maybe it's been 25% of the time we get 0 claims in a day, but really it's probably a range of percentages. And that's what we're going to be doing in chapter 7 is confidence intervals. So there's probably, maybe it's between 0.22 and 0.28. So this gives us a range. And then this one could be between 0.12 and 0.18, and this gives us a range. So then you actually get a range of potential things that could happen. And then insurance companies have to say, okay, how much risk are we willing to assume? Because what if what if these all hit the high side of their ranges? We don't want to sell policies that lose money or else they go bankrupt. And then how much profit margin is there? My wife works in insurance, so there's actually a lot of transparency about these calculations that has to go on. So the insurance commissioners can say, you're not taking advantage, or you're making sure you're charging enough so you can actually pay claims that get, requested. So this is what actuaries do, which is why they get paid a lot of money. It gets very complex, and there's lots of, but it's obviously very mathematical, but there's also a lot of human element. Because when I say what's a risky thing, well, I'm
Depends on the
50.
person.
Exactly, I'm 50. There's a lot of things now that I think are risky, but when I was your age, I did not think was risky. Like jumping. I didn't think that was a risky activity at all when I was your age, but right now it's a risky activity for me because my knees will hurt. So anyway, that's just whatever. This is fun. Thanks for letting me teach.
Yeah, no, it's fun. This is nice for me, to see my instructor and like get like immediate feedback, and if I have a question, it's quickly and easily taken care of.
Yeah, anytime. I love this. All right, so number 6 is another probability one. This is obviously I want exactly 5 to be resolved within an hour. So what's the probability that 1 is resolved within an hour? We know that's 0.6. We want that to happen 5 times in a row. Now we could do this with a binomial, couldn't we? Because it's a yes or it's no, and there's a definite number of each. So this is exactly the same as if I went 5. Let me get my little pen here, and I'm going to thin up my brush a little bit. That's so thick. How do we do that? There, how about that? So if I actually went like 5C0, right? Or 5C5. 5C0 and 5C5 are the exact same number. They're 1. Let's just make it 5C5. I want 0.6 to the 5th power, and 1 minus 0.6 is 0.4 to the 0 power, which is 1. So really, this is worth 1, this is worth 1, which is why you just end up with 0.6 to the 5th. Or a lot of people say,
Yeah, that's pretty straightforward because you're just doing 0.6 like 5 times over. You're just multiplying it 5 times. That's pretty straightforward.
Awesome. Now this one, B gets a little trickier because we're looking at
Yeah, that one tripped me up.
Yeah. Now, for instance, so what's probably that I get at least 1 resolved? Okay, that means I could get 1 or 2 or 3 or 4 or 5. So I could go ahead and I've got, here's the probability, and I could add all of those up, which is very cumbersome, especially if the number's bigger than 5. You could be crunching numbers for a long time. So what's easier here is saying, you know what? I want to take, if the probability of everything happening is 100%, that's everything, 100% minus the probability of the opposite. That's what the complement is. 1 minus the probability of the opposite. So what's the opposite of at least 1 being resolved within an hour? What's the opposite of at least 1?
That'd be 40% obviously because it's 60% getting resolved, so you leave 40% not being resolved.
Yep. And how many times does that need to happen?
Well, it's at least 1, right? But
so if I say I want you to get All right. I want you to. What are you into? What do you like doing?
I
Playing.
like
You got a
football. I don't
gaming
know.
chair. Okay, say you're into video games, right?
Okay.
Let's say you were. All right, let's say you're into video games, and the probability of you winning a round in Counter Strike is 60%. You win 60% of the time, right? And out of the next 5 matches, I want you to find the probability that you win at least one match. So you could say, what's the probability of doing
Okay.
1 or 2 or right? Another way is say, the only way that doesn't happen is if what?
That if you lose all 5 matches.
Exactly. So you take 1 minus the probability of losing all 5.
Gotcha.
And
Okay.
that's the
So we want to do
probability
the
of losing.
inverse since. Okay.
Cool.
Yep. So basically, just the inverse of the first one. When you're so first one is getting all 5 resolved, and B is seeing what happened if none of them are resolved within
Yep.
1 hour.
Very
Okay.
good. So much quicker way to do that. I mean, some people will do it. They'll go 5C5 point, right? And then they'll do 5C4, and then do 5C3, and then do 5C2, and then do 5C1, get all of those, add them all up, and then they get this number here. But kind of forcing you to think about the complement there.
Mm-hmm.
All right, how many would you expect? The expected value or the mean of a probability distribution is just X, or I'm sorry, yeah, whatever the probability of it is, what's the normal probability, right? Times N, the number of times. So what's the probability of success is 0.6, how many times? 5. So we would expect 3 of them to be resolved within an hour. Now, could we have more? Could we have less? Yeah, but the middle is 3. That's expected. And then what's probably that 5 would have their service restored? That's kind of what we did right here. Similar, right? Exactly. Would was probably that none of the 5, yeah. So cool.
Yep, that was pretty good. It was only that B that tripped me up.
Yeah, yep. And then the last one here is all the z-score stuff again and the central limit theorem. And what I'm finding is most people are doing a really good job on this. Most people have done enough practice because we started talking about it in chapter 3, right? And now they're in chapter 6 and they've done a whole bunch of problems on this. They're able to find area left, area right, find the z-score for a percentage, use the formula to calculate it. So that's what this first one is. It says, like, essentially, what's the top cutoff, the top 2.5% of orders? So I like drawing a picture and shading what I'm looking for. Do you have any idea how to find this cutoff for the top 2.5%?
A little bit. I mean, for my calculator, I've been using a website I found for my
Okay.
z-score and then my cumulative property. So I was
Yep.
using website for those, and that helped out a lot. Yeah.
Okay.
I mean, the hardest thing is just for me memorizing, or I guess getting down the equation is my hardest part, is remembering those and which way to use those.
Yeah, there's only if it's an and or an or, if it's a complement, if it's binomial, that's kind of what you're seeing, or the givens. I mean, what's on this exam is kind of what you're going to see. But I'm actually going to pull up the calculator on StatCrunch. Have you used the normal calculator on StatCrunch?
I have, yep. That was pretty helpful.
So I'm just going to show that really quick, and I'll share my screen and just show that if that's all right.
Yep.
I'm just pulling it up here real quick. All right, now I'll share my screen. Okay, hold on. Go back to here. I'm going to switch this over. Stop sharing that. So if I want to share, if I want to find the top 2.5%, are you seeing that right there?
Yep.
StatCrunch. All right, so I go to Stat, Calculators, Normal, and I just use the standard normal calculator. where the mean is 0 and standard deviation is 1. But I do know this gives me the percentage, right? This is like the z-score. This is the percentage. So if I want the top 2.5% and I want to go greater than, there it is. So I know that about 1.96 standard deviations above the mean is a cutoff, excuse me, for the top 2.5%. That's where I got that number.
So wouldn't you need to input the other data, like your mean and your standard deviation into there?
Nope, because that's the beauty of the standard normal calculator. It doesn't matter what mean and standard deviation you have. If it's normally distributed, these proportions are the same.
Okay.
So even if I change this to like, 50 and I don't know, let's say 10 or something like that, and I want the top 2.5% there, then that gives me the score for the top 2.5%, but not the z-score. Now, the reason I don't really want you to switch to the standard, I don't want you to change from the standard normal, is because as soon as you start doing the central limit theorem, which is looking at, instead of just one piece of data, you're looking at the mean for a group of data, it won't work. But if I know the z-score, and I'll show you that. So I'm going to go back to the test now, okay?
Mm-hmm.
All right, stop sharing. Oops, there we go, sorry. Let's go back to here. And let's go back to here. Oops, wrong page. There we go. Okay, there we go. Okay. Am I the right one?
We were back one page.
I was gonna say, that looks like the wrong one. Here we go. All right, here we go. So if I want the cutoff the top 2.5%, you could just straight up do this in StatCrunch and put that mean and standard deviation top 2.5% and get this 8.43. But if I asked you, what's the cutoff for the group of 5, the probability that you would, for a group of 5 orders that would be above that, then it's going to be not going to work. Because then if I said that, you'd have to divide by the square root of 5 here, and then you get a really different number, and then this calculator falls apart really fast. So that's why I say if we just use z-scores, right, 1.96, we're good, and you can just always use that. So that's really the transition we'd love to see happen in chapter 6, is that, we were playing around with it in chapter 3, and I know in the chapter 3 discussion, some people would just do the straight standard normal, some would use the numbers that were given, and both would get correct answers. But now in the central limit theorem, when we're looking for percentages for groups, we got to be more cognizant of this. It would be fine for this one, but the next problem, it would fall apart. So
yep. So sticking with A for 1 minute here. So you do
sure.
1.29, correct? And then times 1.96?
Yes, yep. So we multiply both sides by the denominator here.
Oh, so 1.24. Is that 4 or is that? Okay.
I think it's 1.29, isn't it? Or no, it's 1.24. It's 1.24. My writing is horrid.
Okay, and then you do 1.24 and then times 1.96, and then you just add 6 onto that, and that gives you 8.43.
Yeah, very good.
Okay.
Good job. And then B is almost the exact same problem, except you're looking for the bottom 16%. And if you just remember for the empirical rule, it's -1. That gets you close enough. You can get more accurate, but I don't get too picky about that on this. I'm just trying to say, do you get, oh, that's left, that's a negative. Oh, that's about 16% is one standard deviation. If you use StatCrunch, here, I'll just pull up StatCrunch real quick. If I wanted the bottom 16%, a more accurate is,
I can't see it.
Yeah, it's just 0.994, negative 0.994. So it's like within 600ths or thousandths of a z-score. So it's not like it's a big deal. But most people just recognize it as -1. Or if they went and used their z table and got 0.996, that'd be negative 0.996, that'd be fine as well. And then
so if I was
same
putting
math.
that in the calculator right now, right, for StatCrunch, I would just do 0.16 into the normal calculator.
Yep. and then shade left and see what you get.
That'd be 0.563.
Nope, make sure you put 0.16 as after the equal sign. That's the proportion. 0.16 is after the equal sign.
Oh, okay. Oh, gotcha. Sorry.
Yep. And then does that look like the appropriate shading now?
There we go. That looks better. Yep. One standard
So
deviation away. Okay.
that's why I suggest actually drawing that picture there. So when you do your calculator, you're like, does that look the same, right? Because that last one wouldn't have looked quite the same, right? Because it would have looked,
Yeah.
So that's helpful to have that so you can just match it. So yeah, and then the last one is the middle 95%. And that gets us, notice it's the same. It's 2.5% up here and 2.5% down here, which means it's 1.96. It's the same number. It's 1.96 above and 1.96 below. So there's 1.96 above, which we already did, right?
Mm-hmm.
And then 1.96 below. So that gets you down to 3.56.
Yep. So you just do 1.96 and then yeah, because it's always x equals -6. That's your standard deviation. Okay.
Mm-hmm.
And you just multiply both sides by that
Multiply both sides,
1.24.
add 6. Yeah. So the only difference is that's a negative z-score instead of a positive z-score.
Yep. And then sorry, going back to B real quick. So
Sure, yeah.
So you want to, 16%. So you would do, oh yeah, because you do negative -1 because it's one standard deviation away from,
Right.
okay.
And would you got negative 0.996, right, with your normal calculator?
Yes,
Negative
or
0.9,
negative
yeah,
0.994.
994. Okay, yeah. So do you see how that's super close to -1?
Yep.
Yeah, for your z-score. Yep. So that's why it's good
And
to
at that point, you're already
stick it.
rounded to 1. So yeah.
Yeah, that's what I did here. I just rounded it to 1. If you wanted more accurate, that's great. But yeah. So so I'm just saying, just when you're just, I don't know, talking to somebody, right? And you're like, that, I don't know, that person's in the top 10%. Just having a conceptual understanding of how many standard deviations above normal that is a good thing. You're like, oh, they're in the top 2.5%. Well, that means they're almost 2 standard deviations above normal, right? And then you can, so like an ACT score or somebody's height or their bowling average or whatever it is, right? Even I noticed I've got a handicap in golf. It actually gives me my percentile rank because I guarantee you handicaps are probably normally distributed because humans do them. We notice biological things fall into this distribution. And if you can find an instrument that picks it up, that's usually a decent instrument, is what we'd say. It picks up if the normal distribution kind of falls out of it. Questions on those? You good?
So for C, right, you need both values to get correct.
Yep, because you want the
Okay.
middle 95%. So you've got an upper bound and a lower bound.
So yep, so you just do negative 1.96 and then positive 1.96 for the same exact equation to get upper and upper. Okay.
Yep, very good. Yeah. And this actually kind of leads us into chapter 7 too. Like if we're going to do a 95% confidence interval, the only difference is it's going to include the mean, like we're going to not just look at one piece of data, we're going to look at the average for a group, which will be in the next page here, which I'll flip over to right now. So this one's pretty straightforward. You can actually just use your normal calculator right here. Just type in 0.92 and negative 0.92 and shade between. Or you can say 0.92 and you get, for a z-score, and you get 82% to the left. So let me shade that. So that'd be like 82% is below, right? And then if we change colors here, and then on this one, 17.88% is below that one, how much is in between? It's just the difference. The blue minus the red. The blue was the whole thing before.
So you put this into your Z calculator or
Yeah.
normal?
Yep. Yeah. Okay. Normal calculator. Yeah. Go ahead and put 0.92 in for your Z-score, and what do you get? I wish on that calculator, instead of X, they would use Z, but they don't, because they're thinking of it as a probability distribution, which I understand it is, but
1.40, or no, we're doing it opposite, right? We're not putting.
Yep, you're putting in the Z-score here. You got the Z-score is 0.92.
0.821.
Yeah, there you go. So that's how we got that number right there. And now put in negative 0.92 and you'll get 0.1788. I think your calculator actually has a between feature, doesn't it?
This mine or the StatCrunch? Or yeah, between. Yep, that's between.
Yeah, hit between and then type in negative 0.92 and positive 0.92. And there you go. So if they were different, it would do it. So
0.6424.
There you go.
Sweet. And so
number 9,
we only.
Oh, go.
Okay, so we only use we put it in as the X, right? When it's between, yes. But that's only when it's between.
Nope, that's always your Z-score.
Okay. Oh yeah.
Yep.
Okay.
And the proportion is always equal. It's always giving you the proportion, but you can type in the proportion and then hit compute. It'll give you the Z-score. It'll go both ways for you.
Okay.
So that's why it's good just to play around with that thing and just get comfortable with it. 9 is very typical, just like the problems we just did. Find the Z-score. Again, draw the picture. What's probably to get over 200 inches of snowfall. 200 averages 170 divided by standard. It's 1.5 standard deviations above normal. That's just the probability of that one season. So you could actually just do in your Z calculator, just shade to the right and type in 1.5 for your Z-score. Why don't you go ahead and do that real quick and see if it matches.
I just did, 0.9331.
Right, and then if you take 1 minus that gives you the area to the right. Now you can just tell your normal calculator shade to the right, can't
you?
Shade above. Switch the inequality sign.
Yeah, you can. Yep, and then hold up. Yep, 0.006.
There you go.
Yeah, 0.00668.
Yep. So that's
that's what you actually want to find, right? Is you want to find that little smaller percentage. Okay.
Exactly. Probability that they get above 200 inches of snow. And so what's the probability of getting 25 randomly selected years? Now we're looking for the average of a group. That's the central limit theorem. Central limit theorem, when you do your chapter 6 discussion, essentially, if I keep taking random samples, regardless of what the distribution looks like, I keep taking samples and I plot the means of each of those samples, it becomes normal. So that's really cool. So even if you've got that's what they tell you to do in the discussion, make your own weird distribution. It doesn't have to be normal, make it anything. But if I keep taking repeated samples and I find the means of all those samples and I plot all those means, I get a normal distribution. And it ends up, the standard deviation ends up being the standard deviation divided by the square root of n. So n is the size of each of those samples. So the one you're going to do on
25.
Yeah, in this case, it's 25. Very good. Yep. So now instead of just looking at 1 year, looking at the average for 25 years. So I need to have a lot of weird things happen for a lot of years, right? So probably that happening is 7.5 for your Z-score, which is way off the charts, isn't it? So the probability of that happening essentially is 0. You can type in your calculator, see what you get. It probably will just say 0.00000. Shading to the right there is, it's not going to happen.
Yep.
Now, what if we did find a situation where we had a random selected 25 years and the average was over 200? Then we start thinking 200 probably isn't the average then. And that leads us into what we're doing next, which is hypothesis testing. we could say, let's assume the average is 200. I go out and randomly pick 25 years. I find, or I'm sorry, 170. That's what it is. We'll say the average is 170. I go out and find a random sample of 25 years and it has an average of 200. What's the probability of that happening? Essentially 0, which makes us question, is 170 really the average amount of snowfall? In this case, I'd say there's strong evidence that it's not. It's probably higher than 200. And that's what a hypothesis test is, which we're doing chapters 7 through 9. So you're going to keep doing this type of math in the next 3 chapters. Cool?
Yep. How many more chapters do we have? Because we're on 6 right now, and we have 4 more weeks of class.
Yep. So 7 through 9. And then really we just have 10 and 11. And 10 and 11 are not nearly as intense. The next 3 chapters are the tough ones, and then you kind of glide in from there. So
Gotcha. And is that final week just preparation for the final then?
yep, in the final project. And the final test is going to be optional. The comprehensive final exam you can take if you want to replace an old exam score, one of your other ones.
Gotcha.
But the final project is what you'll be.
But isn't the final exam weighted heavier than the normal test, or you're gonna like just replace it?
It just replaces it. Yep. So essentially you got 3 exams, each worth 15%. Your final project is worth 15%. Your discussions are worth 15%, and then you got your homework that's 25.
Gotcha.
That's right.
And yeah, that final is having me worried because I took this class at this time because the week after this class, I'm going on a family vacation.
Mm-hmm.
And so not knowing I have to do a final project, I'm okay with, but final project and final test would have been a bit crazy.
Yeah, and I've done that in the past, and what ends up happening is people will put too much emphasis on one or the other, and the other one will suffer. I'd rather have you do a good final project because the comprehensive final is obviously a regurgitation of everything we did in the previous 3 exams, plus a little bit on chapter 10 and 11. So yeah, but yeah, the final project.
I'm already working 40-hour work weeks and 9 hours volunteering most weekends.
Wow.
So yeah,
you're working hard.
Pretty busy guy.
Yes, you are.
Trying to get money for college.
I have a son
for college, so
yes.
Yeah. It's not
good
fun,
job. Where are you working at?
I'm doing a marketing internship at Waldinger, and I work at Hy-Vee when I'm not there.
Nice.
And then I volunteer at Lutheran Hope in their production. So each time that's 9 hours, 3:30 to 6:30 on Saturdays, and then 6:30 a.m. to 12:30 p.m. on Sundays.
Whoa. Yeah, that's a.
So when you guys think your 1 hour of church is pretty bad,
yes,
I'm there for 6.
My wife does that sometimes. She sings the contemporary loop. So yeah, she's there Saturday for a long time and all Sunday. Yeah, it's a commitment. So wow, and you're doing it almost every week instead?
Most times, yeah. Most weeks I can. Sometimes I can't because of other obligations, but I always try and do as much as I can.
That's sweet. Wow, that's great.
Keeps me busy.
All right. I think we're almost done. We're getting close. So we're on to 10, aren't we?
Yes.
So 10 is kind of this between, right? Kind of looking at what's between a 78 and an 87, right? We're trying to find this area. And we found out that 87 is 1 standard deviation above normal, which we've already done this, right? It's kind of like 8.8413. You can just say 84, that'd be fine. And I think, what does it say? Find the percentage greater than 87. Oh, they just wanted this. Okay, that's a little different. They want between on the second part, sorry. So it's greater than 0.87, so that's about 16%. You could even just use the empirical rule and go, oh, it's about 1. That's
so 1 above, 16%. Then it's about to be 1 below. Yeah.
Yeah.
That'd be pretty easy.
This one's a little tricky. It just says chop it off at the middle. It's surprising how many people miss this. It's like, what percentage are below the exact middle? They got to know it's 50%. You're in the 50th percentile if you're right at the mean. So that's where this 0.5 comes from.
Okay, gotcha. That's okay. So it's that makes sense now that they're in the exact middle.
Yep.
Because if I put in my calculator, right, if I if I put the 1 in my calculator,
Yep, and then
it
put
is not
0
the exact middle.
between. Yeah, hit between and then put 0 for the one z-score and then put 1 for the other and then see what you get.
Gotcha. Now we're exactly in the middle. Okay.
And the empirical rule, which we did back in chapter 3, was essentially 34% was between the middle and the first standard deviation. So that's kind of rehashing that. Cool.
Yep.
All right, and then the last part here is what score would be needed to be that cutoff for the bottom 10%. Again, you can look that up on your normal calculator. What's the bottom 10% right here? You can find it. It's going to be negative 1.28 on your normal calculator, and then we do the same thing we did before. We solve, multiply by 9, add 78. So the cutoff for the bottom 10% would be 66.48. And the last one is, what's the mean for a group of 16? So now we're looking at a group mean, not just one piece of data, which is the central limit theorem. So that's why you have to do this, add in this divide by the square root of 16 part, which then changes this denominator, which makes it much bigger.
So question. So when you put that in your calculator, did you put in 0.1 for 10%? Or
yes, 0.1 after the equal sign, that's the percentage, right?
Yep.
And then shade left, and then hit compute.
Gotcha. So when it's percentage, it's after the equals, and when it's not the percentage, it's after.
That's the z-scores. Yep, the z-scores.
Okay. Gotcha.
Yep. So it's good just to play around with these. So what I would encourage you to do, and then that ends up being about a 0, 4 standard deviations is a long way. So it's probably of getting a group of 16 students to be over an 87 average is very rare, right? So what I would do is suggest maybe even, doing some more review and stuff before you take it, but just try to take the exam. Pick one of the old ones, just try to take it, look at the solutions, and see if there's any ones. And if there's a particular one, you can just shoot me a question and actually I'm scheduling another office hour. I had a request for one tomorrow at 3:30 in the afternoon on Tuesday.
Okay.
So I'll be posting the recording of this one, and then that we're going to do this again tomorrow afternoon. So
I think I might have missed tomorrow afternoon because I'm working then.
Okay, no worries.
I'll definitely go back and rewatch it for sure.
Yeah, I'm assuming we'll do something similar here or whatever people want to ask. So
it'll be a late night test for me.
Yeah. Well, you'll do good, I think.
Hopefully, that's the goal. That's the goal of all this, is to do well and save some money and save some time.
You know it. Oh yeah, and learn, right?
That too. That might be a little bit beneficial.
Yeah, well, that's my goal anyway. But I understand those are other good goals too.
As a communications major, math is not my strong suit, so
well,
this is not where I shine.
That's the great thing about stats is people communicate it with a lot. Actually, I just went through a training at work, and they used a ton of statistics, and they pointed out the misuse of statistics in the training. It was very interesting. As a stats person, I was very appreciative of that. It was an active shooter training, and the active shooter training said, in colleges, leading cause of death is traffic accidents. Second is
that makes
suicide.
Sense.
So traffic accidents account for 6%, suicides account for like 5% of all deaths, and all shooting, not just active shooters, just all essentially killing from somebody else, homicide is 0.5%, half of 1%.
It really is, yeah, it really isn't that high if you look at all the data. It seems like it's all on national news, but yeah, if you look at like the actual data compared to everything else, like there's more traffic deaths in the US than there are like deaths from guns.
Yes, way more. Yeah. So anyway, I was very appreciative that they actually pulled this up and they showed it on the training. I was like, wow, that's shocking.
That is interesting though.
Yeah.
That traffic deaths are the most. I mean, that makes sense with colleges and kind of being a bit dumber with the rules and breaking a few laws.
just like that problem before, there's a reason why insurance rates are higher for young people.
especially young males.
Yes, they are. You got to get 25 before you get a discount again. So
Yeah.
anyway, well, I appreciate you really just working hard on this and asking great questions and going through this. Is there something else you wanted to go over right now, or how you feeling?
I'm feeling pretty good. I'm gonna probably go over some of this later. I'm getting a tattoo at 1 o'clock today, so that's my big
Oh,
event
cool.
of
What are you
the
getting?
day. I'm getting a cross with a liver ribbon. So, or organ. So I
Nice.
have a liver transplant. So
Okay.
I'm getting a cross, then with the ribbon for organ donation, uh, in the cross.
Nice.
So yeah, something that is meaning and value to me.
Heck yeah, that's the way
So
to do it. Good
pretty
job.
cool.
I have no tattoos, which makes me weird.
My parents don't either. They aren't big on me having a tattoo, but they they're better. I think they now that they know it has meaning and reason to it, they're more understanding of it. It's not just like I'm getting one to look cool. I'm getting it to
Right.
symbolize something.
Well, it looks cool too. So I mean, you got that
Yeah.
going for you as well. That's not the only reason.
It's a yeah. It's also it's just a reminder, of I've been through all this. If I've been through that, I can go through anything. Just
That's
constant
cool.
reminder of like my faith and just my past.
That's wonderful. Well, enjoy getting your tattoo. Just enjoying that pain will seem probably less, very small compared to what you've already endured. So,
Yeah. I'm gonna try and get some numbing gel. So I've heard that helps out a lot.
oh, that's a good idea. I don't plan on ever getting one. So anyway,
They're expensive,
are
that's
they?
for sure. Yes.
All right. Well,
For
it's got
one
to be
hour
worth
for
it.
me is $150.
Okay. Well, that seems, yeah, that's not nothing.
So, yeah.
All right. Well, Tanner,
Okay.
it's great to see you. Let me know if you want to do this again anytime, and I'll post the recording of this for everybody. Okay.
Awesome. Thank you very much.
All right. Have a good one.
You too. Bye.
Bye.